Okay. Next week's quiz will be on KNN, and so you have your chapter, whatever chapter is in Shmueli. But today I want to go through KNN and do an actual application. On the very front page, I added that. It's the very nice description of KNN, advantages, disadvantages. I just want some people to know some general things. So I am going to be going over that. And you see this handout has numbers like 1, 2, 3. I've just added those numbers so it will be easy to reference. All right? So hopefully I will not have problems. So here is the I'm on item number 1, page 2 of 17, and the table that I want to open is credit approval coded jump. Credit approval coded, this one right here. The other one that I will use later on to do prediction is credit approval new. This should be coded new. So this is the new data, but I will show you. Let me save this file. Let me say right click and save this file somewhere on the hard drive. All right. Okay. So I'm going to open credit approval coded.jump. Credit approval coded. We have seen this data set before. Here is the actual decision. This is people making an application to get approved for credit card. The decision 1 means approval, 0 means no. So that's the table. I want to do partitioning. One of the pages at the end talks about the two different ways to create a validation column. One is what I showed you. The other one is via function. So I want to create a validation set. When you create training validation test, the validation data only is called a holdback set or holdout set. So when I say method to create a holdback set, it's really the validation data. And so I do analyze, predictive, make validation column, and I use 60, 30, and 10%. So this is 0.6, this is 0.3, and this is 0.10. Leave this as validation, even though it's a better name. I'm going to use a seed 1, 2, 3, 4. You should know what the purpose of seed is, right? And I click fix random, there are many different ways to create this validation column, okay, to do the partitioning. 60% of 50 is 30, 30% of 50 is 15, 10% of 50 is 5, right? So I click fix random, and the 1234 is if I delete this and go back in and put in seed 1234, I'm going to get the same exact records being in the training, validation, and test. Okay. So that's step 1. Step 2, I put the numbers because it's easy to reference them. I want to do the k-nearest neighbors, so analyze predictive k-nearest neighbors. I know that the method is this. The validation portion is 0.3. number of neighbors 5 because I wanted to calculate the classification or confusion matrix for k equals 1, 2, 3, 4, 5, and it will also tell me the best k, and the best k is the one with the lowest misclassification rate. Decision is ordinal, that's what it means, numeric ordinal, so that's the response. Validation goes into validation, and these are the independent variables or predictors. All right? So under method, you see it has these options. So, oh, I want to put this into factors, the independent variables. I click OK. Oh, I moved the same thing. So the decision is my response. These 5 are the factors. The validation is this. This is 0.3. This is 5. There's a way, if you go to File Preferences, you can set it so it shows up 5 instead of 10 by default. So I click OK. And you see, let me check what version this is using. Help, about jump, 13, okay. So this is the default output. And there's a lot of other things that you can generate here. But let me follow the steps that I have. All right. All right, so I clicked OK, and when I ran what I ran, it was in version 14. That's why. Okay, let's see, what version is this? They're coming to this PC and they're doing, okay, they're doing different things. So let me go to this. And so that you can see the output that, what? So let me save these files so that I will open them. So credit approval coded. So it's in downloads. Okay. So this is version 14. What are you doing? There you go. So okay. It is version 14. All right. So let's see if it will allow me. Unbelievable. All right. So I want to open a table, go to downloads, credit approval coded. All right. I hope that it's not going to be problematic. Analyze, predictive, validation. So, oops. Oh, don't tell me. And continue with 13. This is ridiculous. Analyze, predictive, k-nearest, validation into validation, decision goes here, homeowner. You're going to get slightly different output than what I have in that handout, but that's okay. All right. So there's other things you can display here, all right? We don't see everything that I have on this output, but you see the misclassification rate for training, validation, and test. What it does, it looks at the lowest misclassification rate for the validation, and the K with that is 2. That's where it creates the confusion matrix for that best K. And it does that, the confusion rate for the training, the validation, and the test data. From the 3, the best one to use is test. We're going to be using the validation. Okay, so that was item number 3. Item number 4, you see it has something called a mosaic. Let's ignore that. We're going to go to item number 5. So where it says k nearest, let's show this. Let's show this and the table, because I want you to see, here's the table. So here, I'm going, in number 5, I'm going to say, if I say save neighbor rows, okay, what this does is for this record, these are the closest 5, okay? I don't need to do that, you can delete those, but these are the closest 5 because of that 5 that we had, all right? And then I can go to the, it's different. See, the one below number 5 is the, this was a 14 option, but I can click here and say save predicted, and it's going to show here in this table. So this is a predicted 1, 2. So these are the 5 predicted. So I actually don't need any of this, all right? But I want you to show you. I want to show you these are the predicted ones, right? But let me get rid of them. Delete. The one that I want to keep is save prediction formula. For what K? 2, all right? And when I did that, it gave me 3. I may have had slightly different data, but you pick 2, and it will show you the predicted formula, all right? You need to save the predicted formula here for what we're going to do next. And then the other option there is to publish it. When you publish it, you put it in the, and again, it will ask you for what K, K2. It saves the formula in the formula depot. Okay? And that's an important step. So what I'm doing is slightly different than what I have on the paper, but we're doing the same thing. So on item number 6, this is the formula depot. Depot is a holding place for things. And, all right, and I'm going to compare different models. All right. Item number 7, if you click under formula depot, and you see how it has show scripts, it goes into the script window, it generates some code. We don't care how the code now is generated. You can actually learn to write code directly like that, right? And if I see what I want to do, I want this formula, this code to be applied to new data for which there's no predicted value. So you see, if I click here, I see only this table. What I can do is I can click File, Open, and go to the downloads, and I have the credit approval new coded. This is a table that was on Blackboard. See this table? I saved it, right, on the hard disk. You don't have to. I could have just clicked that, but I want to show you a slightly different approach. So while I'm in the script window, I can pick the one that has the credit approval new coded. Oops, this one. And you see this is new data that you may get tomorrow, later on the same day. There's no decision. And we want to predict using this code. If I now click here, now see I have two tables. So I want to pick this table and then run this. And you have all the steps right here. And you see here, in this new coded, you predict it. So you can copy this and put them here. All right? So what it did, using the data that we had, it predicted this row. So this is a person that went to apply for a credit card, and it was approved, rejected. So this other person is not a homeowner, has a credit score 520, 1 year's credit history, a maximum amount to use 4,000, and they're using 90% of that, which is 3,600. So the decision was to turn this person down. So 101, 001, these are the predicted values. Okay, all right. And I have that in items 8 and 9. All right. All right. Now, 10. 10 was where I selected. 11. In item 11, you see the 1, 2, 3. I pick the new table, I click the run, and 3, you look at the table, and the table is on item number 12. These are the predicted values. I'm going to go back to the formula depot. So this was KNN with the parameters we picked. It turns out, right now, I could actually go and do multiple linear regression if I wanted to. Anytime you change something, you will have a new model. Now, what I chose to do KNN. So I say at the bottom of page 7, after 13, the formula depot has one script. It's this script right here. I don't have to have this open, right? I can just, let me just close it, because if I go with the model number 2 and do show script, it will add the code to this. So let me close this window that has the script, save. You can save it. You can save it. Let me just say no. Hold on a second. Under this, there should be a version that says save to table. Oh, save. See this save script? Somehow it's de-highlighted. If this is highlighted, you can say save to table, all right? But you can also save it to journal. So it creates a window called journal where it saves. If I execute this, look, if I execute formula depot, it will go back and recreate this. All right? All right. But I really wanted to do a save script to table. I don't know why it doesn't enable that. But you can save it in many, many different ways. You can also have a project in a clipboard, blah, blah, blah. And you can put it in clipboard, edit it, and run it again. You can do many things. To script window, anyways. You can generate C code, Python, Java, SAS, SQL code. This is the SQL code, right? So you can save it in many different formats. Anyways, this is model 1. All right, now I'm gonna keep saving to the journal. You see how I'm gonna add things. I'm going to exit from here, not save it. Okay, leave that the way it is. And so that I don't have an influx of many things, I'm gonna close. I'm gonna go back here, and I'm going to do another validation column with different parameters. Analyze, predictive, make validation, and I'm gonna change this percentages. I forgot what I have, let's see. I'm on item 14, and I say, we can go back and change, and I have training 65, 25, and 10. So 0.65, 0.25, 0.10. You can call this another name. Let's call it validation 2. You can also give it meaningful names like validation model 2. If you give meaningful names to what you're doing and people are looking at your reports, that's how people will praise you. All right? And now I pick another number, 1, 2, 3, 5. Click Fix Random. Here is, you see how this list is different than that. So that's the validation that I want to use next time. I do analyze, predictive, KNN. I could be doing some other algorithm, not KNN, right? But I stick with KNN right now. Once again, see, this validation will go into validation. These same independent variables will go into X factor. Decision will go into decision. The validation is now 0.25, 5 same as before, and click OK. I could have kept the other windows open, okay, but now it produces similar output, but now if you look at the validation, it picks the best K from the validation, all right? This is a small data set, so we're not going to have very nice output. Okay? Question? Okay. Now, once again, what you need to do in order to put this into Formula Depot, you need to say here, you can say predicted again, but the important thing is you need to say save prediction formula, all right? What K? 1, it picks up the best K automatically. And if you look at the table, here is the next predicted formula. The previous one, don't worry why it called this decision 2 and this is decision 1. Okay. But this was for model 1, this is for model 2. And next, I want to say, right here, I want to publish this formula into the Formula Depot. And you will see something, when I publish it, you will see a new thing here. Publish, K1, poof, okay. So you have basically, KNN is a lazy learner. There's no model that's being created from the training data. The training data is sitting there, doing nothing. There's no model that has been created. That's why it's called lazy learner. So you say, okay, you're the training data. The time that the training data is used is only when we do this. Now I go here and I will say show script, okay? And this will show here. And once again, I want to apply model 2 to this new data set, all right? You see here, this was produced by, this is the, this was produced by, see this created predictive formula decision 2? Predictive formula decision 2. So that's how you do it. Now here, the next model has predictive formula decision 1. Go by that, right? So what I want to do, right, is run this again, and you will see a new prediction by model 2, right? It just happened to be the same, but it doesn't have to be the same, right? We have a small data set, altogether 50 records. So I have two models here. Now, I am on page 8 of 17, item 15, and see, that's why I ask you if you want to print it in color, because in color you see all these items, all these things in color. So item 15 says, and the formula depot, so obviously this is not the formula depot, so this is out of place. So you can just, I'm going to fix that. But this is what we produced. So then what I do, okay, is item 16. I go, let me close these windows and not save them except the ones that I truly want, so I don't have too many of these things open. Okay, so I go back here and I could pick some other algorithm. Multiple linear regression does not make sense here because I'm not predicting, I'm classifying. I'm classifying here being 0 or 1. But next time I will show you when we do the next algorithm. I will try today to use another algorithm quickly so I can add a new model. Okay, so I want to next go to decision and change the data type column info from ordinal to nominal. Ordinal and nominal, if I, what is nominal? If I ask you to give me your country, right? India, China, India and Germany, I send you, no, I didn't send. India and China are doing an artificial intelligence agreement. They did. These are some of the biggest powers, economic powers in the world. Get involved with AI. Don't stay behind. Do more analytics, data mining things. So you have India, Germany, in the top two, in the top 5 economies, the US, China, India, Germany, France, am I missing somebody? Russia. These are the biggest economies in the world, and they're all doing AI. And you have India and Germany, and I saw this today. They're doing an agreement on AI. What you don't need any greater proof. So get involved, learn more about this. So if I ask you what country you come from, India, China, France, Italy, and you put numbers 1, 2, 3, 4, the 1, 2, 3, 4, they're called nominal because the order doesn't mean anything. But if I put 1 for freshman, 2 for sophomore, 3 for junior, 4 for senior, then 1, 2, 3, 4, it's still categorical data, but it's categorical ordinal, because if you are 4, you're senior, and that means something. It means that you've taken more courses than somebody who is 3. So ordinal versus nominal, read up. So I'm making this change, and you see this change color. Now, it may or may not make a difference in what we are planning to do, but with a lot of things, JUMP treats them differently, and so do many other packages. So I'm going to call that model 3. Model 3 is I change the data type. And so I go through once again, and I'm repeating the process, create a new validation, okay? Create a new validation column. I'm going to call this validation model 3. Model 3. And I use 0.60, 0.30, 0.10. I could change it, but let me just use what I have, 0.6, 0.3, oops. Now, oops. You may get different numbers, probably you will, because, all right, the randomness, 1, 2, 3, 6. Fixed random. Why do I keep, I want to use different seeds. So you're doing an experiment, and you might find out that model 3 has some very interesting properties, especially if you're in the medical field. You want to be able to recreate that sample. You want to be able to go back and ask people that have the same characteristics as the people that were involved in trial 3, model 3. All right. So do that, and you see you have this new validation. All right. So then I want to run through the whole process with this as my validation. So I do analyze predictive k-nearest. This is now my validation. Okay. So JUMP is very nice in everything that I wanted to do so far. And when I used other packages, I had to many times leave the package, go outside. There are other very, very nice packages. JUMP allows you to do everything staying within JUMP. Everything that I wanted to do, I did not need to leave JUMP. And so if you are doing Python, this generates Python code, and you can take it and run it. So this works together with that. So that's that. Here is the decision. That's my response, right? And these 5 items are here. The validation is 0.3 again, 5 again, right? So I'm doing the same things. You see, just because you have columns here doesn't mean you have to use them. Okay? You click OK. You get a similar output. All right. I say similar because the numbers will be different. I want to have these tables here involved, the involved tables to show up. So then I do this. You can save the predicted if you want to in this table, but I don't want to, there's too many things going on. So I'm going to say save prediction formula. And what, so you see here, in the validation, oops, the best K was, this was the lowest, and there's a tie here. So it picked one of the two. I don't know if they have something internal, but the best K for validation is 4, right? And so that's why when I say prediction, it knows the 4 is the 4 from the validation, and it, so now you have, for each model, you need to have a prediction formula in the original table. Okay. This is predicted. I want to see the decision 4. Okay. And then pay attention to this now. It will add the, so this is decision 2, this is decision 1. I don't know if there's a way to see the complete name. But now I want to say, publish the prediction formula. It will prompt me for the best K from the validation, and poof. So now you have model 1, model 2, model 3. And I can click here, do show script. Okay, do show script. Generate C code, Python, JavaScript, SAS, SQL. It doesn't have R. I'm sure there's a way to save it. Show script, and again, you see how it says new column. It's using the formula. So if I go here, and oh, this is the new. Where's my other table? And I right click and pick formula. This is the formula that it generates. It's a crazy thing right here. Right? So I want to make sure that I'm using the formula that is saved in here, this formula. I pick the new records, I run it, and then I get the prediction. All right, so I have the same thing throughout, but it doesn't have to be the same. Okay, this is where I stopped with 3 models in my handout, but let me try to do, and if we're not, well, let me actually finish with this and then try to do something new. So I'm at the bottom of page 9 of 17, bottom of 16. So now we have these 3 models, okay? And you can do model comparison. So you can then go to, let me close things that I don't need, close this, go back to the original table, okay? And now I can say analyze predictive model comparison. In the latest homework, there was a question to pick the best 3. I will try to go over this part to show you over that part of the homework. So model comparison, and you see here, when you want to compare models, you have to have these predicted formulas here. That's why you need to save the predicted formulas to the original table. So you pick these predicted formulas and you put them here. Okay? That is on item 17. All right? There's some of the columns here which we can choose to ignore. This group, I could have another column. Let's say I had millions of rows. I could have a column called country or continent. So I could group my results. I could, if I had 3 countries, let's say United States, France, Spain, I could group by country, and then you would repeat the same thing for United States, France, and Spain, right? So then you click OK. Now, I don't have a lot of data, but you have, I got different numbers. The last one was zeros. But if you have more data and you have, then you will have values for this. So the misclassification rate is the same, but you know, if you have bigger tables, and I will try to dig up a bigger table, then you would, the best model is the one with the smallest misclassification rate. Okay? Now, let me try something here. I want to see analyze predictive, something that you don't have. Let me see, do I have anything else here? Oh, Let's go back again. Analyze, predictive, model comparison. So I put these three. How come it? Okay, I guess one of these. 1, 2, 3. Seems like a 4 here, but okay. All right, click this. When you are here, that's where you can generate ROC curves, and they're not going to be meaningful. But if I do ROC, because I didn't have a nice data file, you can create an area under the curve, so it will compare the three. You can create lift curves. So these are not really meaningful because we don't have good data. I'm going to try to dig up a good data set so we get nicer curves. And you can also do confusion matrices for the various predictors. And so you can do, you can truly compare the models. Okay. Now, if I do model save script, now it turns it up. If I save it to data table, and this is model comparison, I'm going to call this model comparison Dimitrios, all right? And I click OK, look where it saves it. So that's why I was looking for it before. See, right, this thing right here? So let me close all of these. The great thing, I don't think, let me leave this open just in case. But I can close everything, I think. Let me do this. Close everything, take a chance, I'm not, what the heck. So if you save this table, save as, right? You can save it, and you can say something like with best 3 models, all right? See, next time you open it, let's close these two. Let me go to the hard drive. File Explorer. I'm doing meaningful examples because I've done these things. So where did I save that? Oh, there it is. You see this table right here? If I double click it, this is here now. It's saved, and if I click this, just click on it, it goes and does all of that comparison. Right? This is neat. I showed you the process. I didn't have a good enough table, and you can do the cumulative gains curves, all right, which is really, really nice. So this, okay. At the end of this, I appended this is a one-page guide how to do KNN. It doesn't have everything. Then this shows the 2 different ways to create a validation column. The second method is by using this function. Follow it, and you should be able to do it. Model comparison is what we did, and if you have more meaningful data, then when you compare the models, you can pick the one, for example, RMSC is, that's not too nice. RMSC is a very good way to compare models. So from the 3 models, the one that has the smallest, the lowest RMSC, this is a good way to pick the best model. I will try to, at some point, I gave you copies of this before the midterm, how you can do text analysis, and I will try to expose you to as many things as possible. but first we need to finish certain material. But if I can find a small window of time, I will do that, because just by knowing to do textual analytics, you can look at the company's legal documents and find out, for example, if a document has been meddled with. You have a document and you can run an analysis to find out, for example, word count and everything, and certain things being there, important key things, so that if somebody, electronic espionage with all the problems that we have, then you see the file later on, you can do analytics and produce the same thing with the same seed, and you can see if it changed. Very nice. You can start your own company just with the stuff that we're doing. Now, let me go to the homework you turned in. This homework, you had the answers. Which file was involved to try to find the 3 best models? Was it Boston Housing? Takeo?
Yeah, it was Boston Housing.
No, it was Takeo something.
Eh?
It's Takeo, right?
Takeo only, purchase only.
It doesn't matter what it is. I'll pick one of them. It doesn't matter. I'll go through the process. So this here is Boston Housing, okay? And this is supervised learning. Here is the dependent variable, and I want to predict a value for a new house. I should have I want to have new data as well. So let me go here. Okay, it doesn't matter what the table is. I mean, I don't care. And here I do it with SPSS actually and something else. But let's get to to something here. It doesn't matter what the table is. So sometimes you'll get a validation column as part of the data. What I recommend is create it yourself, but it's there. So I do analyze fit model. Okay, the price is the Y. Then I get these guys as the independent variables. This is my validation. All right, and this is the ordinary least squares method. All right, but for now we can just run it, and you can just get a model, right? The model is obtained by looking at this, right? Right. So your model will be y hat equals 10,425 minus 4493 times age minus 2413 times mileage and so forth. By the way, this profiler is a neat tool. What it allows you to do is this. See, if you wanted to find the price based on the age being 25 years old and mileage being the age of a car, 25 months, I mean, the mileage on the car was something. If I move this, what is this? This is the age. If you lower the age, or if you increase the age, it shows you how the other parameters are affected. So, and it shows you the predicted price and a range. So if you change the mileage, if you increase the mileage, right, you see how other parameters the values are affected, then it will show you as you're changing things, then it shows you the price and a confidence. This will be like a 95% confidence. So this 8993 should always be between these two numbers. It's just a neat tool to do. It's an interactive tool. All right, so we did this, right? Now I want to go back to, so this is without picking the most significant predictors. If I want to pick, well, you can pick the best predictors, but I can go back. Let me close this. I don't want to have too many of these things open. I can go back and say analyze fit model. By the way, it's a good idea to keep this open so that I don't have to go and open it every single time. Price is here, age, through this, go here, validation, go here, and I keep this to be open. All right, then I will say stepwise. See, I click run, and after you click run, this is still open, so if you make a mistake and you close this, you don't have to, it's right here, right? You click run, and when you are here, you can ask it, now how many independent variables do I have? 1, 2, this doesn't count, it's the intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I can tell it, I want you to give me all the possible models, including up to 11, because I have 11 independent variables. And you can make this, I mean, this is in hundreds what you can get combinations, but leave it to 56. So this will generate 56. So this is all the, where's the one? Let me do it again. See, right here. That's why having that, click run, right? And then stepwise, all possible models, 11, 56. And see, if you click here, it de-highlights some of these things. All the possible combinations of only when you have one independent variable, when you have two, and the highlighted one, this is the best of all the two independent variable combinations. But what you can do is you can RMSE, root mean square error, square root of the mean square error. If you right click there and you say sort by column, I want to sort by this in ascending order, click OK, then you will get, look at the top 3. So these are the top 3, because these are the lowest 3 RMSEs. This goes from smallest to largest. So what you can do is this. So click on this, and you see that the values from here show up over here. See this 0.8611, that's the R square. CP should be close to this, should be actually close to 8 plus 1 or 9, but we picked the best based on RMSE. So now what you can do, this was the best model by using RMSE because it was the smallest. Then you can say run model. So what is your model here? See, this had 7 independent variables, which are 1, 2, 3, 4, 5, 6, 7. You have your model from here. Plus you have cross-validation, and you have the ANOVA table, and you have, you see all of these p-values? They're all 0, means all these independent variables are significant. Okay. So, can I save this somewhere? Save script, to data table. I'm going to call this fit group 7. Click OK. And then close this. I go here and I pick this as the second model. The values from here are over here. Then I click Run Model, and I save this under in the data table as fit group 8 option 1, because there's another one with 8, and close this. And in my table, you see how I have fit group 7, fit group 8, 1. Then I pick my third model and do the same thing. Save this with save script to data table fit group 8 version 2. Poof, a new one is added here. And if I close all of these and then save this table, right? Save this table. I can just click this and you get this. I click that and then I click that. And you can compare them one right next to each other. This is good stuff. Some of you will go to interviews. I want you to mention everything that we're doing in class in your interviews. I'm trying to bring up examples that are very close to real life. These are real life stuff. And you'll find out, you'll go and you'll interview with people that will tell you, so what are you doing? Can you help me? Okay. Now, you see with this model, because I'm predicting, did I close? Well, I have 3 different models. I do not get the classification matrix because I don't have classes 0 and 1. I'm not classifying things to 0 and 1. Instead, you have these things, the RMSE and so forth. Let me see. I was trying to find an equivalent way to save this, each one of these in which one is that? Oh, that's a credit approval. Analyze this model. Anyways, it's a different way to show the formula, but we're running very close to the quiz time. But I showed you how to compare different models. Are there any other questions with what you did on the homework? Okay, you can always come even after you get your homeworks back, all right? So why don't you close everything? Close everything. Close book, close your